Okay, so moving on to B, all we have to do is that we have to actually just sub in this 2 into the equation. So we've got limit x to the 2, so all we have to do is sub it in since we don't have any other problems in this equation. So we end up just doing something like this. So you go 2 to the power 3 plus 2 times 2 minus 4. Now this is how simple limits are, and limits are pretty much giveaway marks. Hope that you can get the best out of this as you can. So you end up getting 2 to the power 3, which is 8 plus 4 minus 4. So these two cancel out, and you just get 8. So your final answer is limit x to the 2, x3 plus 2x minus 4 is 8. Okay, so continuing on for question 6ii, we're basically going to have to figure out the limit of x going to 2 in x to the power 3 minus 8 over x to the power 2 minus 4. Now since if I just sub 2 inside, this would equal 0, it's not possible. Therefore, the first step is to factorize. So, factorize. Now, the factorizing of this is quite difficult. Since it's a cube, we need to use of difference of two cubes. Now, it states that x to the power 3 minus y to the power 3 equals. Now, this is the formula that we're using since it's a negative over here. So now, let's do this. What I like to do is I like to pretty much write it out in the beginning. So, what's my x value? So, x equals just x, right? And what's my y value? Now, if this is y cubed, my y value would be the cube root of this, which is just pretty much 2. So now what we can do is we can go for this formula. So we have x minus y, so x minus 2, and then we have x squared, so just x squared, plus xy plus 2x, because 2x, and then we get plus y squared, so y squared is just 4. Now, that's pretty much it. What we can do now is we can just solve this normally. So here we go. We've got x squared minus 2, and then we've got it times by x, x minus 2 times by x squared plus 2x plus 4. And now, since this is difference of two squares, you should have been able to figure that out. It's just x minus 2 and x plus 2. Okay, now this makes it a lot simpler. We've got limit x to the 0, x to 2 still, and now we can just basically cancel out these because they're timesing, and we have this left. So we have x to the 2 plus 2x plus 4 over x plus 2. Now let's see if this works out. If I did limit x to the 2, so x to the 2, would it work? Let's have a look. 2 plus 2, so it's 4 over 2 squared, 4 plus 2 times 2, which is 4 plus 4. So we end up getting, well, 12 over 4. And that is our answer, believe it or not. Our answer is 12 over 4, which can be further simplified to 3. Hope this helped. Okay, so now question 6c. This is probably one of my favorite type of questions, first principles, because it's so goddamn easy. Now, I'll explain why it's so easy, because it's just a matter of substitution, really. Now, what I really do is that when I first see this, I break it down. I know that f to the y is, well, just f to the x, we'll just say fx, is equal to x squared plus 3x minus 8. Now, what I need to find is fx plus h, so let's just do that. Now all you have to do is substitute this x plus h into where all the x's are here. So that's exactly what I'm going to do. X plus h squared plus 3x plus h minus 8. Now, what we can actually just do here is we can expand this already. So we can just say, you know, x squared plus 2xh plus h squared plus 3x plus 3h minus 8. Now, that's our fx plus h. Next, we need to know the general formula, which is just this. Limit h to 0. You have fx plus h minus fx over h. It's as simple as that. Now, since you've found both fx and fx plus h, you can just sub it straight in. So here we get this. We get limit h to 0. It's important we write this so the mark actually knows we know what we're doing. So fx plus h. So we have x squared plus 2xh plus h squared plus 3x plus 3h minus 8. And we'll just put brackets around it, just to show that that's its own function. And then we have minus, we'll put bracket around fx. So we just got x squared plus 3x minus 8. Now, here is the main thing about principles. Now, first principles. What we really have to do is that we have to get something at the top which is all divisible by h. H has to be a common factor that we can take out. The main reason is that we want to get rid of this bottom h so we can just simply sub our limit in. Now, how we're going to do this is not that hard, and it can be done pretty quickly. So if you think about it, at the top, I'm just going to further simplify this. So since the minus is timesing all this, I'm just going to write this here. So x squared plus 2xh plus h squared plus 3x plus 3h minus 8 minus x squared minus 3x. So I'm just going to make that more clear. Minus 3x plus 8. So now we can see quite a few things cancelling out. I'm going to use a red color just to show you. This minus 8 cancels out with this plus 8, positive 8, so these two cancel. And then we have the x squared cancelling out with negative x squared, so that goes as well. And we're left with this function over h, obviously. So now let's just put it in. We've got limit h to the 0, and we have 2xh plus h squared plus 3, and wait, my bad, the 3x actually cancels out here as well. Sorry about that. Plus 3 h, oh wait, yeah, 3h. Now that's it, over h. Now, out of this, it's obvious. You can take the h out from the top. So we're basically just factorizing it. So limit h to 0. We have h 2x plus h plus 3 over h. Cancel, cancel. And we're left with this. Now, if you put h as 0, if we substitute all the h's as a 0, what would we get? So that we would get something like this. 2, oh wait, my bad. We would get something like this. So we'd get 2x plus 0 plus 3, which is just 2x plus 3. Now, a good way to check this is just go back to the original question. Okay, now if you differentiated this without using first principles, what would you get? So you'd get 2x plus 3. That means we are correct. And that is pretty much it for question 6C. Okay, so this question should be quite easy. All it's asking us to do is find the second derivative of y. So let's find the first one first. So we have f dash y equals 20x to the 4 plus just 6x to the 2. Now finding the second derivative, so f double dash y equals 4 times 20, which is 80x to the 3 plus 12x. That's our second derivative, and that is our answer. Okay, awesome. So moving on, find the second derivative for 1 over 3 minus x all to the power of 2. This is pretty easy as well, and should just be pretty goddamn easy for you in the test as well. So if you have a look, 1 over anything is just this minus 1. So that's just going back to the indice rules that we have for differentiation, and I'm sure you guys can remember, or if not, you can just pretty much revise that. So all we have to do for this is, we don't have to do the quotient rule, because there's no two functions of x, it's just a 1. So we can basically just pretty much do this. So you have 3 minus x to the 2, or brackets, negative 1. Because that's the same as saying this. We haven't actually differentiated yet. So for our first differentiation, right, I'm still simplifying. So simplifying this again, 3 minus x. And these two just times each other, so negative 2. And we get this negative 2 here. And all we have to do now is simply times this, use the chain rule. So the chain rule goes something like this. Negative 2, 3 minus x. And this is a negative 3, and now times negative 1, so that, and we end up getting 2 3 minus x to the negative 3. So that's our dy dx. We still haven't found the second derivative, so we can just do that now. So we have to find d2y over dy to the power 2. So now let's do that now. Negative 3 comes in front, we get negative 6, 3 minus x, this is to a negative 4, times by negative 1, we end up getting 6 to the 3 minus x, and that's still negative 4. That's our second derivative, and that is our answer. If you want, just as an extra, you can actually put this over a fraction again, so you can give the answer in a fractional form. So, as we know, using the laws, you have 6 over 3 minus x to the power of 4. So that's pretty much it.